Hello everyone. First of all, thank you for joining my session today. My name is Mohammed Sayerwala and I'm a senior software engineer at Emphasis Corporation. I work on enterprise front-end development and large-scale application modernization. Today, I'd like to talk about AI-assisted modernization of legacy jQuery applications to React. Although React has become the standard for modern web development, many enterprise organizations, especially in banking, healthcare, and government, still rely on large jQuery applications that were built 15 or even 20 years ago. These systems continue to power critical business operations every day. Replacing them overnight simply isn't practical. So the real challenge isn't building a new React application. The real challenge is modernizing an existing application without disrupting the business. In this session, I'll share an AI-assisted approach that helps engineers understand legacy application, identify migration opportunities, and modernize them incrementally, while keeping experienced engineers in control of every architectural decision. Before we discuss the solution, let's first understand why legacy modernization is such a difficult problem. Modernizing legacy application is one of the biggest challenge organization faces today. Most of these systems were built long before component-based frameworks like React became popular. Over time, new features were added without fundamentally changing the architecture. As a result, many applications accumulated significant tech debts. One JavaScript file might contain business logic, API calls, event handling, validation, and DOM manipulation, all mixed together. Because everything is tightly connected, changing one feature can unintentionally affect several others. Another major challenge is the lack of clear component boundaries. Unlike React, where every feature is encapsulated into reusable component, jQuery application often manipulates the page directly, making it difficult to determine where one logical feature ends and another begins. Shared state and hidden dependencies make this situation even more complex. Variables are often modified from multiple places and different modules communicate through undocumented event chains. Have you ever opened a JavaScript file expecting to make a small change only to discover hundreds or even thousands of lines of interconnected code? That's exactly the challenge many organizations still face today. At this, where AI can make a significant difference not by replacing engineers, but by helping them understand complex legacy systems much faster than manual analysis alone. So how do we tackle the problem of the scale? Let's begin by looking at today's roadmap. Here's what we will cover today. We'll begin with AI-driven code analysis and see how machine learning identifies potential React components within a legacy application. Next, we'll look at dependency classification and how it helps determine the safest migration sequence. We'll then discuss the hybrid coexistence layer, which allows jQuery and React to work together throughout the migration. After that, we'll explore how AI-generated regression testing helps preserve application behavior during modernization. Finally, we'll bring everything together through a practical four-phase modernization roadmap that organization can follow to reduce risk and deliver value incrementally. By the end of this session, you'll have a structured framework for modernizing legacy application using AI while maintaining engineering governance. Now that we have outlined the roadmap, let's look at the core philosophy behind the entire approach. AI-assisted human-in-the-loop approach. One principle remains consistent throughout this presentation. AI is an assistant, not the decision maker. Today, AI tools can analyze code, detect pattern, generate component suggestions, and even create regression tests. But enterprise software require much more than code generation. It requires architectural judgment, business context, compliance consideration, and accountability. Those responsibilities still belong to experienced engineers. That's why this approach follows a human in the loop model. The process starts with AI performing static analysis to understand the application structure and identify relationship between different modules. It then detects recurring UI patterns and proposes candidate React components. Notice that I say proposes. Nothing is migrated automatically. Every recommendation is reviewed and approved by engineers before implementation. This creates the best of both worlds. AI accelerates analysis by processing large code base quickly, while engineers apply their expertise to make the final decision. One lesson I have learned from the enterprise modernization is that AI is excellent at finding patterns, but only engineers can determine whether those patterns make sense from a business and architectural perspective. That's the philosophy that guides every step of modernization process we'll discuss today. A common misconception is that AI can automatically convert an entire jQuery application into React with a single prompt. In reality, enterprise systems are far too complex for that approach. Instead, AI acts as an engineering assistant. It begins by scanning the entire application and understanding its structure, including modules, event handlers, shared state, DOM interaction, and dependencies. Think of it as creating a detailed architectural blueprint before starting a renovation project. Once the application has been analyzed, machine learning identifies a recurring UI pattern that could become more reusable React components. Finally, the AI generates candidate React component. I emphasize the word candidate because every recommendation is reviewed and approved by engineers before implementation. One lesson I have learned from the enterprise modernization is that AI is excellent at finding patterns, but it doesn't understand business intent. That's why successful modernization combines AI speed with human expertise. Once AI understands the application, the next question becomes how does it decide what should become a React component? One of the biggest challenge in migrating from jQuery to React is identifying the right component boundaries. Unlike React application, jQuery systems weren't designed around reusable component. Features were added over many years, often by different teams, making the application highly interconnected. To identify logical component, the analysis engine looks at three key signals. Reuse frequency, which is the same UI used across multiple pages? State mutation scope, which is which variable affects a specific part of the interface? And event handler co-location, which function consistently works together. Rather than relying on an outdated documentation, AI learns directly from how the application behaves. Let me give you a simple example. Imagine you are modernizing an online banking application. The customer profile section looks like a straightforward widget. However, after analysis, you discover it connected to customer validation, fraud checks, audit logging, notification, analytics, and several backend APIs. What looked like a simple UI suddenly becomes one of the most interconnected modules in the application. Without understanding those relationships, migrating it first could introduce production issues. Instead of spending weeks manually tracing code, engineers receive intelligent recommendations that help them identify logical business component much more quickly. Once we have identified our component, the next question is, which one should we migrate first? Successful modernization isn't measured simply by the number of React components we build. It requires measurable indicators that show whether the migration is progressing safely. These include component discovery, dependency mapping, coverage, consistency, time to first component, and the effectiveness of the coexistence layer. Together, these metrics help engineering team understand progress while giving architects, project managers, and business stakeholders objective visibility into the modernization effect. One thing I have learned is that successful projects aren't driven by assumptions. They are driven by measurable progress. Once we can measure the application, we can begin on answering one of the most important questions in the modernization. What should we migrate first? Migration should never be driven only by business priority. Technical dependencies are equally important. Our approach classifies dependency into four categories: data dependency, event dependencies, shared state dependency, and indirect dependencies. Understanding these relationships helps engineers estimate migration risk before writing a single line of React code. Let me illustrate with a practical example. Imagine an organization wants to modernize its transfer fund page because it's a high priority feature. The React page is ready, everything looks complete, but dependency analysis reveals that it still relies on legacy authentication, fraud detection, shared validation, and notification services. Migrating it immediately could introduce subtle production defects. Instead, dependency analysis helps us assign a migration risk score. Low risk components are migrated first. Higher risk modules remain until their supporting infrastructure has also been modernized. This transforms migration planning from guesswork into a structured engineering process. Once we have classified dependencies, the next step is making those relationships visible. One question I often hear is, why can't we simply replace jQuery all at once? Well, for small applications, that's possible. For enterprise applications supporting thousands of users, it usually isn't. The business cannot stop while application is rewritten. Instead, modernization must happen incrementally. That's where the hybrid coexistence layer becomes essential. During migration, jQuery and React run side by side. Whenever the legacy application updates data, it publishes a structured event. The event bridge receives that event, standardizes it, and React component subscribes to those updates. This allows both technology to communicate without being tightly coupled. Here's a practical example. Imagine a customer onboarding application. The customer search page has already been migrated to React, but account details and document upload still run on jQuery. When a customer is selected, both the React and jQuery part of the application needs to display the same information. The event bridge enables that communication seamlessly, allowing organization to modernize one feature at a time without interrupting the day-to-day business. Now that React and jQuery can coexist, the next challenge is understanding all the relationship inside the application. This is where dependency graph becomes incredibly valuable. A dependency graph provides a complete picture of how the application is actually connected. Unlike React architectural documents, which are often outdated, the dependency graph reflects the application's current state. It exposes hidden relationship, circular dependencies, and highly connected modules that would otherwise be difficult to identify. For example, a notification service may appear to be an isolated feature. But once we generate the dependency graph, we discover it is used by account management, payment processing, loan approvals, fraud detection, and customer onboarding. That insight completely changes how we plan the migration. The graph also helps determine the migration order. Using techniques like topological sorting, engineering teams can identify which components are safe to migrate first and which should remain until later. If there's one takeaway from this slide, it is this: you can't modernize what you don't fully understand. The dependency graph provides that understanding. So far, we have focused on understanding the application and planning the migration. The next challenge is ensuring that migrated application behaves exactly like the original. That's where the AI assisted regression testing comes in. So far, we have focused on understanding the application and planned the migration. The next challenge is making sure the migrated application behaves exactly like the original. This is where regression testing becomes critical. Traditionally, engineers write regression tests manually by interpreting requirement and practicing how users will interact with the application. While this works, it's time consuming and often misses edge cases that exist in production. Our approach takes a different path. Instead of relying only on the documentation, AI learns from how the application is actually used. It captures production behavior, including user interactions, application state changes, and network activity, and uses that information to generate candidate regression test. Let me give you a simple example. Imagine a customer updates their contact information. To the user, it looks like a single action. Behind the scenes, however, that update may trigger address validation, audit logging, notification services, analytics events, and backend synchronization. A manually written test might verify only that the address changed successfully. An AI generated test based on real production behavior is much more likely to capture the complete workflow. Again, engineers review every generated test before it's added to the testing pipeline. The goal isn't to replace the testing team, it is to help them create tests better reflect how the application is actually used. Now that we have looked at the analysis, migration, and testing, let's bring everything together into a practical modernization strategy, which is the modernization roadmap. One of the biggest reasons modernization projects fail is that organizations try to transform everything at once. Our approach avoids that risk by breaking modernization into 4 manageable phases. We begin with quick wins, where low risk and independent components are migrated first. This allows teams to validate their approach and demonstrate early progress. It even gives them confidence that the modernization is achievable. Next comes the core user's journey, the business critical feature that the user interact with every day. During this phase, React and jQuery continue working together through the coexistence layer. The third phase focuses on complex integration, where highly connected modules are modernized after the surrounding infrastructure has already been simplified. Finally, we reach decommission, where remaining legacy code is retired and the application runs entirely on a modern React architecture. What I like about this roadmap is that every phase delivers working software. The business continues operating, users continue receiving updates, and engineering team reduces technical debt without taking unnecessary risk. In this approach, even if business wants to add any new enhancement to the existing application, those can also be incorporated while the modernization is in progress. This will not make the application come on hold until the entire modernization has been completed. We can have our day-to-day updates, enhancement, and the transformation or the modernization work parallelly. Modernization doesn't have to be a massive one-time project. It can be a series of small, well-planned improvements. And this approach can easily fit into the agile methodologies which the companies usually follow, rather than going through an entire waterfall approach of migrating the entire jQuery application to React and then doing one big bang deployment to the production, which is highly likely to have production issues. Of course, technology isn't enough. Successful modernization also requires strong governance. Especially in industries like banking, healthcare, and government, modernization isn't just a technical change. Every challenge or every change must also satisfy security teams, compliance teams, architects, and business stakeholders. That's why governance is built into every stage of this approach. We continuously monitor migration progress, maintain regression test coverage, document architectural decision, and ensure every deployment can be rolled back if necessary. One thing I have learned throughout my career is that stakeholders rarely resist modernization. They resist uncertainty. When engineering team can demonstrate measurable progress and controlled risk, modernization becomes much easier to support across the organization. Throughout this presentation, one idea has remained consistent. Let's revisit that principle one final time. The human in the loop principle. Throughout this presentation, we have seen AI analyze applications, identify component, classify dependencies, and generate regression test. Those capabilities can save engineering team a tremendous amount of time. But AI is only one part of the solution. Enterprise software still requires human judgment. Experienced engineers understand business priorities, compliance requirement, long-term architecture, and the trade-off involved in the every technical decision. That's why every AI generated recommendation remains exactly that, a recommendation. Engineers review it, architect validates it, development team decides whether it belongs in production or not. The future of the software engineering isn't AI replacing developer. It's helping developers making better and faster decisions. That brings us to the final message I like to leave with you today. The key takeaways and closings. As we conclude, I'd like to leave you with 4 key takeaways from today's presentation. First, understand your application before you modernize it. A dependency graph provides the visibility needed to make informed migration decisions. Second, incremental modernization is far less risky than a complete rewrite. Allowing legacy and modern technologies to coexist enables organization to deliver value continuously while reducing disruption. Third, AI is most effective when it supports engineers rather than replaces them. From code analysis to regression testing, AI accelerates repetitive tasks, but experienced engineers remain responsible for architectural decisions. Finally, a successful modernization is about people and process as much as technology. Clear governance, measurable progress, and collaboration across engineering and business teams are what make a long-term transformation successful. That's one message I like everyone to remember from today's session. It is this: legacy applications don't need to be discarded overnight. With the right strategy, AI can help us understand complex systems, reduce migration risk, and modernize them one step at a time. Thank you very much for your time and attention. I hope this session has provided a practical perspective on how AI can support enterprise application modernization. I'd be very happy to answer any questions if you may have. Thank you very much. You guys have a good one.